In this lesson, I'm going to talk about the least squares regression line. So what I've done here is I plotted, in this case, 5 data points. These are my raw data. And then I drew a line, which is my eyeball of the linear, the best fit line. And what the least squares regression line does is, of course, it used the x bar, y bar because you're supposed to. It finds the x bar, y bar point, wherever that might be. And then it measures the distances, the vertical distances between every point and a candidate line for what it thinks might be the best fit line. Now, those are the vertical, in this case, deviations of the data from the line that's a candidate. Then what it does is it squares all of those deviations, because remember, some of them are positive, some of them are negative. It squares them and it tries to minimize the sum of the squares. So when you add up all those squares, it's trying to make that a minimum. So it'll adjust the one edge up or down and the other edge up or down. Of course, it's basically rotating about the mean point, wherever that might be. And it's trying to reduce the squares of those vertical deviations. Now, it turns out that if y equals ax plus b, or if you want y equals mx plus b, but we're going to go with ax plus b because that's the way the calculator is going to report it. If y equals ax plus b is the equation of that line, then a, the slope or the gradient, is given by this calculation. Luckily for you, you do not have to memorize that. You do not ever have to even calculate it. You will let the calculator do that for you. However, if this is A, and you know x bar, y bar is a point on the line, you can solve for B by subtracting, and so B is going to be y bar minus ax bar. Again, you do not need to know that either, because the calculator will find B for you as well. Now, this least squares regression line, which is the one I just described, where it finds the vertical deviations from the mean, from the candidate line, these vertical deviations, it squares all of them, adds them up, and tries to minimize that sum. That's called the least squares regression line, which is also often referred to as linear regression or just the regression line. This is the standard way of finding the best fit line or the linear regression. Now, I do want to also mention that the correlation coefficient R is one of the things we're going to be looking at. As you know, if R is positive, you have a positive slope. R is negative, you have a negative slope. The closer R is to either positive 1 or negative 1, the closer the data is to that line. But we're also going to look at R squared, which gives a more meaningful description of what is going on with the line. So R squared, if you think about it, is going to be a positive number. And the way that it is described, what R squared tells you, is if R squared is, let's say, 0.93, convert that to a percent so that it's a little bit easier to understand. So if R squared is 0.93, we are saying that based on our regression, 93% of the variation in y is associated with the variation in x. So if R squared is exactly 1, then we're saying 100% of the variation is y is associated with the variation in x. In other words, as x changes, y changes exactly. If R squared is, let's say, 0.93, then we're saying 93% of the variation in y is associated with the variation in x. And then the remaining 7% is something else. So that's the easiest way to describe what R, or in this case R squared, is calculating. Now, we did in a previous lesson look at values of R and whether we consider correlation strong, moderate, etc., etc. And again, those values are reasonably good to look at as well, but R squared can give you a little bit more precise of a value or of a description. Before we start talking about using the calculator to find the linear regression, we need to set something up. So on the TID4 calculator, go to a blank screen, and then hit the second button and then the catalog button, which is right above the 0. So second makes it blue, and then you're hitting catalog. You may notice now it is in alphabet mode. So you hit the button that says X inverse. What you're actually hitting is the D button. So you're now moving the catalog to the Ds. And then scroll down using your up and down arrows to where it says Diagnostic On. And then hit enter when you're next to Diagnostic On, and now you'll get out of the catalog and it'll now say Diagnostic On, and you'll have your flashing cursor, and you're going to hit enter one more time. And after you hit enter one more time, the calculator should say done, and now we are ready to do what we need to do with the linear regression. Now you should only ever have to do this once. However, if your calculator gets reset, it's possible that the diagnostics will be turned off. I'm not sure why TIA decided that the default should be diagnostics off, but for linear regression, you have to have the diagnostics on. Otherwise, you won't get your R or your R squared. That's the key. You want to be able to get the correlation coefficient. So if you ever have to reset your calculator before you do anything else, turn on the diagnostics, and that way you won't have any issues with your linear regression. All right, now that we have our diagnostics on, we are now going to calculate a linear regression. So I've got some data here. It represents the annual income and the average weekly grocery bill for a bunch of families, in this case, 8 different families. And the annual income is measured in £1,000. That symbol there is pounds. I'm assuming this is British pounds, but what do I know? So X thousand pounds is the income, and then the grocery bill is being measured in just Y pounds. So this family here earns 55,000 pounds a year and spends 120 pounds a week on groceries. So that's how to interpret that data. So what we want to do is we want to find the equation of the regression line, and then of course we're going to interpret the gradient. So we're going to use the calculator to do that. Now in this region here, I'm going to describe the calculator steps and buttons you have to use. I'll describe what the screen looks like over here, and of course this is where I'm going to write my work that you have to report on a test or quiz or homework or whatever it might be. So first we hit the Stat button. That brings up a screen that looks something like this. It'll highlight Edit over here, and then there's Calc and there's Tests and so on, and there's a bunch of stuff down this list here. And the first selection in that list is Edit. We like that. We want to edit. So we hit Enter. Now the screen will look something like this. It'll have L1, L2, L3, and so on. And there may be some data in the various lists. We need to clear all that data out. So we scroll using our up and down arrows until we are highlighting L1. Now we want to clear the entire list, so we hit Clear, and then we hit Enter. And that should now clear L1. So now we scroll over to L2, or we may have to go up and then over to L2. And again, we want to highlight L2 and then clear that. So we hit Clear, and then we hit Enter. So now we scroll using our left and right arrows down to right here underneath L1, and we start typing in the income or X values into L1. So we should have all the values, all 8 of the X values in L1. So now we use our right arrow to go into L2, where our cursor will now be at the top of L2 waiting for us to enter values. So we go ahead and enter all the Y values, all of these values into L2, and make sure they line up correctly so that these are paired up correctly. So there should be 8 values in L1 and 8 values in L2. So now second quit to a blank screen. Now this next part is not part of the question, but it's worth knowing how to do, which is we're going to graph this data on the calculator. So hit second stat plot, which is right above the Y equals second stat plot. So the screen will say stat plots, and it'll have 1, which is plot 1, and 2, etc., etc. We're going to go to 1 and hit Enter. And that should take us to plot 1. So the plot one screen should look something like this, and we want to make sure that plot one is turned on. So use your cursor, use your right and left arrows, whatever, to go to the on and hit enter on on. And then the type should be the first one, which is a scatter plot, not one of the others. So make sure that is highlighted. And then XList should be L1, and that's probably the default. So if it's not, then hit the second, and then whichever L button you want. So there's 1, 2, 3, 4, 5, and 6. So if it says L5, then go to second L1 and it'll switch it to L1. Or if you happen to put your data in L5, then you should select L5 for that one. Y list should be L2. Mark, I like the square, but there's a few other possibilities. And if you have the T84 plus color edition, then color is an option over here as well. So once all of the correct things are highlighted, we hit the zoom button. And it brings us to our familiar zoom options. And we want zoom stat because this is statistics. So you can hit the 9 button and it'll bring up zoom stat. So the calculator will now graph the data. It doesn't give you X and Y axes necessarily, doesn't necessarily give you a scale, but what it has done, it has created an X minimum, X maximum, Y minimum, Y maximum, so that all of this data fits nicely into the available space on the screen. Now again, all of this stuff I taught you about using the stat plot option on the calculator is not part of this particular problem, but I thought it would be nice to be able to see how it's done. What we need to do now is find the equation of the regression line. So we hit the stat button, and then we scroll over to calc, and under the calc list, we find for linreg ax plus b. So you either scroll down to the for linreg ax plus b, or you just type the number 4 and then enter. So now this screen should show up. It should say X list, and it probably defaults to L1. Y list, it probably defaults to L2. Frequency list should be blank. So if any of those are different, make sure you go over to there and change it. Remember, in order to change the list, you do second and then whatever numbered list you want. And in order to remove it, so to empty this, you just go over there and you hit clear. And now what we want to do is we want to store the regression equation so we don't have to keep typing it every time in case we want to use it for anything. So I'm going to store the regression equation. So I want you to, after you've entered these 3 things in, we want to put our cursor right there. So I'm going to use this space here to continue to write instructions because I ran out over here. So we are now our cursor sitting right there. So at this point we hit the vars button. Then it brings up this screen. We scroll over to Y vars. The first option there is function. And we hit enter when it's selected function. And under the function menu, it has Y1, Y2, Y3, and 1 should be highlighted. We like Y1, so we're going to hit enter one more time. So now we come back to this screen, and now it says XList L1, YList L2, frequency list is blank, store reg equation now is in Y1, and we now want to calculate. So we scroll to calculate and hit enter. And so the calculator reports this, linreg, y equals ax plus b, a equals this number, b equals this number. I've got the r squared and the r. Remember, r squared is the one that represents percent in a better way, but r is the one that IB is going to expect. That's actually the correlation coefficient anyway. So in this particular case, it did not ask for the correlation coefficient, but we are going to need it eventually, so keep track of it anyhow. What we were asked was to find the equation of the regression line. So using this, I'm going to write down the equation of the regression line. It's going to be y equals 4.18x minus 56.7 when I do my rounding to 3 sig figs. So again, I used A for slope and B for the y-intercept. Be very careful. Sometimes there's an E something here, so it's written in scientific notation. Don't just read the first few digits and say, oh, I'm done. Make sure you look at the very end to double check that there's no scientific notation being used, because if you lose that, you're way off of what the correct value is supposed to be. Now I'm going to go ahead and write the R value anyway, just so that we have it for our records. R is approximately 0.8 0.95, which is a pretty strong linear regression, or sorry, pretty strong correlation. So now the question is interpret the gradient. So the gradient here is 4.18. Now 4.18 is rise over run. So we're saying that the grocery bill is rising by about 4 pounds and 18 pence, 4.18 pounds for every run of X, or 1,000 pounds in income. So that is the interpretation of the gradient. This is what the gradient means. A rise of 4.18 pounds in grocery bills per week for every 1,000, because as X is measured in 1,000, for every 1,000 pounds of annual income. And again, it's an approximation because the data didn't fit perfectly. Now, very quickly, I recommend that you hit the graph button just so that you can see now the line drawn in the middle of that data. This wasn't something that was asked for in the problem, but it's still an interesting thing to do. Now, I do want to mention one more thing, and that is you need to turn your stat plots back off if you're going to do other math. So in order to turn the stat plots back off, one way to do it is to just do second stat plot and then scroll down to plots off and then hit enter on that, and it should turn on the plots off. The other way is if you just hit the Y equals button, you'll see at the very top it has the plot 1, plot 2, plot 3, and they may be highlighted, and you can go up to those and then hit enter and unhighlight them. Make sure that the stat plots are all unhighlighted before the next time you do any graphing with your calculator. Now the problem continues, and I'm going to take the relevant information from this page and copy it onto the next page. So again, here's the relevant information. There's the linear regression equation. Here's R squared. We've got income, which is X thousand pounds. Grocery bill, which is Y pounds. This was approximately the data. I've put a scale here so we have a general sense of what the data looked like. I didn't bother drawing the regression line through that, but you could do that as well. So part B says, estimate the weekly grocery bill of a family with annual income of $95,000. Now, X was the income, so I want to put 95,000 in for X, except X was in 1,000 pounds, so I'm just going to put 95 in for X. So to do this, I do Y is equal to 4.18 times 95 minus 56.7. And I get approximately, let's say, 340, because it's 340.4. So we say about 340 pounds. Now it says if a family spends 100 pounds a week on groceries, estimate their annual income. So 100 pounds a week is the Y, so I'm going to plug Y equals 100 and try to solve for X. So I have 100 equals 4.18X minus 56.7. So I can add 56.7, 156.7 equals 4.18X. So X is now going to be 156.7 over 4.18. And again, I'm going to round that to 3 sig figs. And I get approximately 37 point, let's say, 50. 37.49 if you want to do pennies. But I'm going to go with 37.5. And so what we're saying is about pounds, 37,500 annual income. Now finally it says comment on the reliability of the above estimates. So the estimate B, that's the one where we predicted the weekly grocery bill of an income of 95,000. Well, that's an extrapolation because the highest income here was in the 60-some thousand range. So 95,000's extrapolation is an extrapolation and therefore not reliable, not very reliable. However, estimate C. So that's an interpolation because we had an annual income of 37,500 or 100 pounds a week. That's definitely inside of it's an interpolation between about the 30,000 and the 60 whatever thousand it was. So it's an interpolation. And the correlation is strong. Remember, just because it's an interpolation doesn't mean that the line is giving us meaningful information. But if R is 0.895, that's pretty strong. So it is pretty reliable. So extrapolation, just off the bat, not necessarily reliable. Interpolation could be reliable if your correlation is also strong, which it is in this case. And that's the end of the lesson.